Welcome to Lecture 2.2, Addition Property of Equality. So I want to cover some terminology first. The first one is solution set. The solution set for an equation is the set of all numbers that when you use in place of the variable, make the equation a true statement. So in essence, gives us the correct answer. For example, x plus 2 equals 5. The solution set would be 3 because when x is 3, 3 plus 2 equals 5. That is a true statement. Therefore, the solution set is 3. Is 5 a solution to 2x minus 3 equals 7? Well, we'll have to plug in 5 for x to see if it is a true statement. 2x minus 3 equals 7. Let's plug in 5. 2 times 5 minus 3 equals 7. We're not sure, so hence the question mark above it. 10 minus 3, does it equal 7? Yes, 7 equals 7. It's true. So 5 is a solution for the expression 2x minus 3 equals 7. Let's try another one. Is negative 2 a solution to 8 equals 3x plus 4? Now before you say yes it is or no it isn't, we need to work it out. So let's plug in negative 2. 8 equals question mark 3 times negative 2 plus 4. 8. Again, I'm leaving it as a question mark. Negative 6 plus 4. 8. Does it equal? Negative 6 plus 4 is negative 2. No. 8 does not equal negative 2. It is a false statement. Okay? So we do need to know what an equivalent equation is. It's two or more equations with the same solution set are said to be equivalent, or to be equivalent equations. For example, x plus 2 equals 5, if you remember our solution set is 3, as well as x equals 3. They are both equivalent because both have the same solution set of 3. A minus 4 equals 3, a plus 2 equals 5, a equals 7. They're all equivalent because if we have 7 for a, the solution set is 7, and they're all true. So they're all equivalent equations because they all share the same solution set. Now where this comes in handy is our property of addition property of equality. For an algebraic equation for a, b, and c, if a equals b, then a plus c equals b plus c. Adding the same quantity to both sides of an equation will not change the solution set. It may change the look of the actual expression, but it does not change the solution set. For example, x plus 6 equals 5. Let's add negative 6 to both sides. X plus 6 minus 6 equals 5 minus 6. X plus 0 equals 1. X equals negative 1. So although we change the look of it, negative 1 is the solution even to the original problems. Negative 1 plus 6 is 5. And now, negative 1 is the same solution set to x plus 6 minus 6 equals 5 minus 6. They look different, but they have the same solution set. And then you want to verify your solution. I put negative 1 back into the original equation, and yes, indeed, 5 equals 5. Now, using the concept, let's solve for x. X minus 5, I'm going to add 5 to one side, as well as add 5 to the other side of the equation. X plus 0 equals 17, so x equals 17. And again, we want to verify our solution, so let's plug in 17 wherever there's an x. 17 minus 5 equals 12. 12 equals 12. Yes, that checks. Let's solve for a. A plus 3/4 equals 1/2. Well, a plus 3/4 minus 3/4 equals 1/2 minus 3/4. If you haven't figured it out, I'm always going to add the opposite of what is being added to the variable. And if I do that, the whole goal is to get 0 on the one side and leave the variable all by itself. That goes to 0. But I have to find the common denominator, which will be 4. So 1/2 times 2/2 minus 3/4, which equals 2/4 minus 3/4. So our solution set is -1/4. Again, you always want to plug it back in to verify that indeed you do have the correct solution. So -1/4 plus 3/4 equals 1/2. 2/4 equals 1/2. I can reduce to 1/2, and yes, indeed, it does check. Let's try decimal problem. And I'm going to rewrite this so my x is on the far left. X plus 7.3, just for ease. I'm going to subtract or add a negative 7.3. X plus 7.3 plus a negative 7.3. What I add to one side, as long as I add it to the other side, I'm okay. Plus a negative 7.3. That goes down to 0. That's the whole point. 7.3 negative 2.4. I like vertical addition. 7, 9, negative 9.7. Now I would recommend that you plug this back in and verify that your answer is correct, but I'm not going to do that right now. Here's a problem where we have x's more than just solve x. We can combine like terms and then solve for x. So I'm going to combine all my x's. Negative 1x plus 2x is x plus 2 equals 7 plus 5. We can do the math there. It's 12. I'm going to do it vertically. Minus 2 to both sides. X equals 10. Again, plug it into the original problem. So 10, negative 10 plus 2 times 10, does it equal 7 plus 5? Negative 10 plus 2 plus 20 is 12 equals 12. Yes, indeed, it works. Let's solve for a. I have distributive property. 4 times 2a is 8a. 4 times negative 3 is 12, negative 12, pardon me, minus 7a equals 2 minus 5, negative 3. Combine like terms. 8a minus 7a is a minus 12 equals negative 3 plus 12 on one side plus 12 on the other side. I'm left with a on one side of the equation, and 12 minus 3 is 9 on the other side of the equation. Again, plug in your solution, verify to see if it works. 4, 2 times 9 minus 3 minus 7 times 9 equals 2 minus 5. 4 times 18 minus 3 minus 7 times 9 is 63 equals 2 minus 5 is minus 3. 18 minus 3 is 15. 4 times 15 minus 63 equals negative 3. And 60 minus 63 equals negative 3. It looks like we did everything right. Negative 3 does equal negative 3. All right, one more. 3x minus 5 equals 2x plus 7. I have x's on one side and on the other side, but that rule applies even for x's. So what I'm going to do is I'm going to subtract 2x from the right as well as 2x from the left. I'm left with x. 2 minus 2 is 0 x's. So now I'm going to rewrite my problem. X minus 5 equals 7. Now I can eliminate the 5 on the left by adding a 5 to both sides. Minus 5 plus 5 is 0, and I'm left with x equals 12. Plug it back in and verify that your answer is correct. 3 times 12 minus 5 equals 2 times 12 plus 7. 3 times 12 is 36 minus 5. 2 times 12 is 24 plus 7. 36 minus 5 is 31. 24 plus 7 is 31. 31 does equal 31. And a final note about substitution. So although the addition property of equality, we stated for addition only, we can subtract the same number from both sides of an equation as well. So subtraction is just defined as the addition of the opposite. So if we have x minus 2 equals 3, we can add 2 to both sides. X equals 5. Or if x plus 3 equals 4, I can subtract or add the opposite, minus 3 plus minus 3 on both sides. That's adding the opposite. X equals 4 plus a negative 3 is 1. Okay. So that's all for this lecture. So until next time, be seeing you.